Hi, this is Scott Allen Miller here on Sam IT. Today we're going to take a step back to our career discussions and we're going to look at whether you should go into software engineering, SE, or development, coding, that kind of stuff, IT, information technology, or business infrastructure, or CS, computer science. So let's start with defining each of these things. Let's start with software engineering. This one has the least terminology around its name, but is really the best known. Software engineering is the art of making the majority of the world's software. These are the people who make everything from video games to Microsoft Word to that bespoke business application that your company uses that you hate and no one maintains. All those things are made by software engineering. They may not be trained software engineers, they may not be good software engineers, they might be amazing software engineers, but it's all software engineering. This is what a lot of people refer to as your developers or your coders. It's what people who go to school to make software go for, right? That's software engineering. They make products. They are the true engineers of the technology space. They're the most well understood, most commonly visualized people. Now, IT, or business infrastructure, information technology. This is the group that works for a specific business and provides solutions for that business. And solutions may include support. These are the people who typically use the products or deploy the products made by the software engineers. So these, as a group, tend to be administration. Now, because it's infrastructure, you still have engineers. But if you think about software engineering is a little bit more like mechanical or electrical engineering, designing products, and IT, while it has a lot of administration and support, does have engineering, but its engineering is more like civil engineering, where they're building infrastructure, not products, right? Civil engineers provide solutions to urban planning or crossing a river or something like that, whereas your mechanical or structural engineers might provide material science information that helps them ensure that their struts are able to withstand a certain amount of weight. Now, that's IT. IT always has the context of a business because without it, there's no infrastructure to support. That's the context that makes IT what it is. Just like civil engineers need a municipality or civilization to support. That's their context. Software engineering doesn't need a context. They can make software for software's sake. They might have customers, they may have goals, but they could just make things because they want to, and it would still be software engineering. It might not make money, but it would still be software engineering. Now, the hard one to describe is computer science. Computer science has a tendency to have its name applied broadly to basically anything technology, and this is unfair to computer science majors because CS is a very specific, very demanding field, and it's not good for them to have a whole lot of people refer to everyone else who doesn't do things even remotely computer science as CS people. So what is CS really? Well, if we were to think of software engineers as kind of being like engineers, hence the name, computer scientists are like theoretical physicists, hence the name scientist. They're researchers. Now, because of the way that computers work, computer scientists still work in code. They still do their experiments in code, but they work more in math and less in business. Software engineers tend to use a lot of pre-built things. They tend to build things that are practical, that people can use. They build off of pre-existing patterns and algorithms. Computer scientists are the ones who develop patterns and algorithms. They make the compilers. In many cases, they're the ones who make the actual databases and the actual operating systems, or they're heavily involved with them. They're doing the research. They're doing the things that fundamentally make software able to do what it does. So CS is a research field. These are the people who are most likely to sit in universities or to only exist in the very largest of research organizations. So of course, companies like Facebook and Google and Microsoft hire a large number of computer scientists, as do governments, as do intelligence agencies, because these are places that are looking to do things like implement new encryption algorithms, new sorting algorithms, new deep science, deep investigation algorithms and techniques. Computer science does research, but rarely turns out product or tangible results. They will take what they do and hand it to software engineering, who will then make products. Those products are then handed to IT, who implements them for a business in the real world. This is the pattern of how things work. So when you are looking at what you want to do with your career, assuming you want to be within the technology space of the way that these come together, you need to think about, do you want to be a researcher and spend your time doing mostly math and some really hard coding that tends to be in assembler or in C? It could be in something else. It could be Python. You could just be doing, sort algorithm research, but you're probably going to be doing loads of math and really, really under the hood detailed programming. Or do you want to produce things that people actually get to see and touch and use, but you still want to sit and write code almost all of the time? Then probably you want to be in software engineering, where you're going to be producing tangible products that people can actually touch and feel and use and understand what it is you made. Or do you want to be helping a business solve its business problems using technology that these other groups have created for you, and implementing solutions that you may purchase, or you may simply implement, or you may build yourself by taking lots of building blocks and putting them together? IT might assemble a network from physical components, or it may assemble an application stack by putting together an operating system and a database and a platform and some specific applications, and tying those things together and then supporting them and checking performance and building scale out options and providing storage for those things and security. That's what IT does, building the actual final solution that end users actually implement or get to use. Three very related but extremely different fields, all that tend to be confused. When you're looking for what you want to do, you really need to think about whether it's what you're pursuing in a resume, or more importantly, when you're going to university and you want to take classes. Watch out for a lot of people who think they want to be in IT will take CS classes, because lots of people, especially in the high school space, don't have any idea about this field or any of these fields, and simply use computer science as a catch-all. And even worse, some universities also use it as a catch-all because, one, they don't know what computer science is, and that's a terrible sign that you attend a university that doesn't even know what the subject matter is they're supposed to be teaching. Or even worse, they do know what it is and they don't care, because it's generally cheaper to supply IT training than it is computer science training. So it's a common thing for universities to label their IT classes CS as an attempt to scam their students. That's worse than just honestly not knowing what it is. Both cases are really bad. Of course, good universities have computer science programs that are actually computer science, but you don't want to go into a computer science program wanting to do IT, because if you go into a real one, you will learn nothing useful for IT. I mean, nothing. There is no crossover between CS and IT. CS and SE, yeah, there's some crossover. SE and IT, yeah, there's some crossover. But the distance between CS and IT is so extreme that you will simply lose those years as far as your actual education. Worse, if you want to go into IT and have CS as your degree, it looks like, to people who know anything about IT or CS, that either you took the wrong degree and didn't understand what you were doing and never corrected your path along the way, which is bad, that you went into a university that was faking their degrees, which is really bad because it makes your degree look completely worthless, and again, you didn't leave the program or didn't figure it out along the way that you were being scammed. All bad things. Or it looks like you went into CS and decided it wasn't the career for you and you went into IT. That's the best case scenario of all of those, and it's not great because it suggests that you probably either failed out of CS or failed out in the real world. You may have gotten your degree, but once you hit the real world, you couldn't cut it. And it makes people wonder, pretty much assume, that you're in IT because you're slumming it, not because you're passionate about it. And it guarantees to them that you weren't passionate enough to have gone to a legitimate program and or known what program you wanted to go into and or made those decisions before you got out into the field. The best case scenarios aren't that good. Yeah, it's totally possible that you went into CS, were successful at CS, you might have been the best computer scientist ever, you worked at Google, you did amazing research, and then one day you said, you know what, I want to change fields, I want to shake things up, I want to do IT, and that's perfectly acceptable. You better be ready to defend that when you go for an interview if CS shows up on your resume somewhere, because people who have no idea will overlook it But do you want to work for people who don't even know what field they're hiring for? And people who do know will wonder why you went for CS and then went into IT, which is completely different than going for psychology or business or art history and moving into IT. Because those are fields that people regularly do for fun. You don't take those because you're looking at getting a career in those specific things. You do them because you're looking for a rounded liberal arts education. CS programs are not rounded liberal arts education. They're heavily focused research degrees that don't apply like general liberal arts do to going after IT and other business related fields. Now, of course, there's other things we should mention quickly. One is bench. Bench I don't include in this list because it falls to the other side of IT. It is the physical technology solutions without a business context. That's where we're not making business solutions, and we've had lots of videos that talk about this, so you can look those up. But Bench does not have a university counterpart program, so we kind of leave it out, because if you're going into Bench, you don't have the same background infrastructure, and you don't have the classifications. A lot of things that most people who work in Bench don't even know they work in Bench. They simply aren't in IT but doing technology and call themselves IT in most cases. But it's a huge field, Bench, but it's very poorly identified, and there's lots of different names for it. But because it doesn't have a university program, we don't have any standardization, whereas all these others do have pretty decent standardization at good universities, and globally. It's not a thing unique to one nation. The other program that's worth mentioning is computer engineering. This one is often also lumped in with these, and in reality is completely unrelated. Computer engineering is a subset of electrical engineering, which is part of traditional engineering. It is not part of the technology world. It's not related to computer science or software engineering or IT or even Bench. It is simply related to electrical engineering. That's the field. It's the very specific field within electrical engineering that focuses specifically on making the components of computers rather than more general components, because electrical engineering could be anything from making relays for legacy telephone networks or transformers for power conversions from a wind farm or just about anything. But computer engineering tends to be super specific within the electrical engineering field, so it has its own programs. Just like manufacturing systems engineering is a subset of industrial engineering, just because there's some things you can focus on, so sometimes specific degrees get created. But a computer engineer is really an electrical engineer and could call themselves that, and a manufacturing systems engineer could call themselves an industrial engineer legitimately. They're just a focused one. So, given that, I hope that this helps you, and please comment below, ask questions, get involved. It's a great discussion, it's important, and it's not just important to understand what these different aspects of the field mean. It's also important for you to do some, personal introspection and think about what you want from your career, what you want from your job. Do you want to be doing research? Do you want to be creating products? Do you want to be implementing solutions? They're very different day-to-day tasks. It's very different what you deliver. It's very different how you interact with people. CS tends to be extremely non-social. Software engineering tends to be moderately social, but with large amounts of solitude, at least to be effective. And IT tends to be extremely social because you're part of the business. And CS is completely tech. Bench is completely tech. But software engineering and IT both have a tendency. Software engineering may be completely tech, but tends not to be, and IT can never be completely tech. IT is primarily business. So you get very different aspects of your career from each one separately. Thanks for joining me. Remember to like and subscribe, ask your questions below, and if you want to support us here on Sam IT, you can do so on Patreon.